You and me both. So, what we're working on today, the last time I saw you, we were talking a little bit about functions and relations and what the differences between those were. And today we're going to talk up specifically about what we call linear relations. Linear relations just means we're talking about lines, right? We're talking about the equations of lines. And the cool thing about a linear relation is it's always going to be a straight line. You're always going to get a straight line out of it. And so what it really means is if I have points, okay, this is a really terrible graph, but pretend it's a graph, right? Say this is my x axis and this is my y axis, right? And what it says basically is when the points on a graph all kind of lie along a straight line. So if I had points like, let's see if I could actually make them in a straight line. I'm pretty bad about that. So if I have the points on a graph and they all kind of lie along, oops. I was doing good with the points and then I had a terrible time connecting them. So when the points on a graph all lie on a straight line, we call it a linear relation, right? It can be represented by an equation, like you can see it as like ax plus by equals c. These should actually be capital. It should be like ax plus by equals, well, capital C just looks like lowercase c, right? And that is what we call the standard form of an equation, right? This ax right here, this would be just some number, right? Some number might not be any number. If it's one, we don't even write in the a, right? Same with b, right? It's going to be whatever is in front of the y, some number. And our variables would be x and y, and this would be just some other number. And when we have it in this form, I don't think it's very useful. I think the standard form of an equation is the dumbest form of all of the forms. And the reason for that is that the most useful form is what we call the slope-intercept form. But we have to start with the standard form to get to the slope-intercept form. So the first thing we have to know is that when I'm dealing with the standard form, that is not an A, B, and C all have to be greater than or equal to 1 for it to be standard form, right? That means I can't have like a -2 for A. I can't have a fraction for A. It always has to be in a whole number form. I should say a natural number form because it can't be 0 either. And then the greatest common factor of all of them has to be 1. And the reason for that is otherwise we would simplify it to a smaller factor. So what do I mean by that? If I have an equation, for example, like -5x plus 6y equals -12. This kind of looks like it's standard form, right? But we talked about how A, B, and C have to be greater than or equal to 1. And in that case, we don't have that happening here because of this negative, right? And as a matter of fact, this negative. So this negative doesn't matter. I don't even know what I'm talking about. The only thing that has to be greater than or equal to 1 is a. That's confusing it with the next part. So just our a term, right? Whatever is in front of the x, right, has to be greater than or equal to 1. Can't be a negative number. Our equation can't lead off with a negative. Any ideas on how I would change that to not be a negative anymore? The only thing that can't be negative is that 5 in front of the x. Everything else can be negative. Aiden, is there a reason that you're never on camera for me? Thank you. If you want to change a negative to a positive, you just have to multiply it times another negative, right? If I want negative 5 to be positive, I'm going to have to multiply this whole thing times negative 1. Because when I multiply something times negative 1, all it does is change the sign. But I have to do it to everything. I can't just do it to one thing, or I'm messing up my equality. So negative 1 times negative 5 is 5x. Negative 1 times 6y is negative 6y. And negative 1 times negative 12 is just 12. And that would be put in the standard form of an equation. Now, the first several problems that you're going to have on your worksheet are going to be asking you to write the equations. You're going to be given a series of equations and you're going to have to write them in standard form. So we're going to do a couple more and then talk about slope-intercept form. If I have y equals 2x minus 9, and I need to put it in the standard form, we have our ax plus by equals c form. We can notice that this x term needs to be on the other side, right? It needs to be on this side, right? So all we have to do to make that happen is it's a positive 2x, so I could just subtract 2x from both sides. And I get minus 2x plus y equals negative 9. And so we're getting closer to this ax plus by form, right? We have our x value on the left, we have our y value on the left, and our just constant term, you know, our thing without a y, x or y, on the other side of the equal sign. The only thing wrong is that we still have a negative on that x, and we need to change it. And so to get it to the form we want, we're going to have to multiply everything by negative 1. When I do that, I get 2x minus y equals positive 9. Because when we multiply times negative 1 or divide by negative 1, all it does is change the signs of everything. And now we've got it in that standard form of the equation. And so that being said, we are now going to talk about how we get it into what we call slope-intercept form, or a useful form of an equation, right? So the cool thing about slope-intercept form is we don't have to like get it to standard form and then get it to slope-intercept form. We can get whatever form we are starting with and move it to slope-intercept form. And slope-intercept form, I know you guys have heard of, because when I talk about writing equations, the one thing people always seem to remember, even if they don't remember exactly how to use it or what it's for, when I talk about equations, people always tell me y equals mx plus b. right? That's the one thing they remember. They might not necessarily know what it means to say y equals mx plus b, but people remember y equals mx plus b. Does that seem familiar to you guys? You guys remember y equals mx plus b? When we're talking about y equals mx plus b, we call it slope-intercept form for a reason, because mathematicians, they are not that creative. If it says slope-intercept, it's because it's going to have what we call a slope and what we call an intercept. So if we look at y equals mx plus b, m is our slope, and b is our y-intercept. Now, a y-intercept is just a point on the y-axis, right? So we would know where to put a point on that y-axis, that up and down axis in our graph. If you remember when I drew the graph before, we had x and we had y, although that looks like an x, y, right? It would, so anything that would be b right here would be some point on this line, right? Whatever the number is. If it's 2, it would be at y equals 2. If it was -7, it would be down below at -7. But what this b tells us right there is where that point is, right? And what the slope tells us is how to find our next point. You guys have probably heard about slopes. Slopes are that rise over run that we used to talk about all the time. And the cool thing about a slope is if I have one point on any graph and I know the slope, I can find the next point. How does that work? Well, let's talk about the 4 types of slopes, and I can kind of show you. So when I have slopes, there's 4 types. We have a positive slope, and that would be, pretend these graphed lines are straight. I'm going to write them all out, and then I'll show you what the slopes actually look like so I could do it in a different color. We have positive. We have a negative. We have a 0 slope. And we have an undefined slope. And so when I'm talking about slope, a positive slope is just the slope of a line that goes up from left to right. So if it's going up from left to right, the slope is positive. Negative is a slope that goes down from left to right. A 0 slope has no slope at all, right? It is just a horizontal line, right, that has no tilt to it at all. And an undefined slope is a vertical line. So, excuse me. A 0 slope would look like just y equals some number. Afterwards, we could say y equals 3 if this was 3, and it would just be a line across where y is 3. An undefined slope looks like x equals some number. So say in this case it was 3, it's just where x is 3, we would have that vertical line. when we're talking about slopes and we're talking about finding points and graphing lines, and this is kind of more the more important part of what we're getting into, because we're moving into graphing a little bit. We're not going to spend a ton of time there. So for those of you who hate graphing, don't worry, we're not going to be there for forever. But the reason we like that slope intercept form is if we know the slope and we know the y-intercept, we can graph something pretty easily. And what do I mean by that? If I have, for example, y equals 2/5 x, right? 2/5x plus 7. I can graph this equation fairly simply, right? If I have an xy axis, this is my y and this is my x, and I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can go 1, 2, 3, 4, 5, 6, 7. Everything's positive, so I'm not going to throw in any of the negatives. What we said when we talked about slope-intercept is we said that this is a y-intercept, right? That means we know at 7 on the y-axis, 1, 2, 3, 4, 5, 6, 7, there is going to be a point. We know that. But what the slope tells us is it gives us our rise over run. We're saying that from that point, we can go up 2 spots and over 5 spots, right? They're both positive, so we can go up 2. What does that look like? 1, 2. And then from there, I could go over 1, 2, 3, 4, 5. And I would have my second point. Why is that good? Because it only takes 2 points to graph the equation of a line. So from there, I can connect those 2 points and I have the equation of the line. Sometimes you'll see them written in functional notation. What I mean by functional notation, we talked about it a little bit the other day. We talked about functional notation where we had f of x. Just consider f of x to be y, right? So if I have f of x equals negative x plus 2, that's the same as saying y equals negative x plus 2. Here's a question. We know that 2 is our y-intercept, right? Because that's our b. We're set up in that form, and we know where our b is. We know that if I was going to graph this, my starting point would be at y equals 2, right? We know we'd have a point. Hopefully, I can actually change my color. We know we'd have this point here at 2, right? Our slope is just negative. What that means, if you don't have a number in front of that x, it's just 1. The number's 1 if there's no number. So that is negative 1. And we would write that as a whole number, it'd be negative 1 over 1. If your slope is negative, it doesn't matter if you make the numerator negative or the denominator negative. It doesn't matter if you make your rise negative or your run negative. Either one is okay, but you can only do one or the other. So if I keep the negative up top, right, if I make my rise negative 1, right, that means I would go down 1. And then I would take my run, this bottom part, in the positive direction, 1. What does that look like? Well, okay, here we go. Let's go. We the -1 means I would go down 1, and then in the positive direction 1. And then I could connect those 2 points to make my graph. Does that make a little bit of sense? Okay. Sometimes you are going to have to put them in the right form. Sometimes you're going to be given a problem like x plus 3y equals -15, and you are going to have to write it in the slope-intercept form. But putting something in the slope-intercept form just means solve it for y, right? The only thing I have over here, I have this x. I'm going to subtract out that x, both sides, and I have 3y equals -x minus 15. I still have that 3 on the y. I need it to say just y equals, which means I have to divide everything by 3. And I would be left with y equals -1/3 x minus 15 divided by 3 is just 5. And then I am in that slope-intercept form. The nice thing about slope-intercept form, for those of you who hate fractions, a fraction in the slope is no big deal because all it's telling you, the top part tells you how far to go up or down, and the bottom part tells you how far to go left or right. So you don't have to figure out the fraction, right? So when we go to graph a problem like this, it's fairly simple, right? Because what we know is that we have a point at 1, 2, 3, 4, 5, at -5. 1, 2, 3, 4. Just making some lines here. Now, my graphs aren't pretty, right? Because I'm not evenly spacing everything, but they're a general idea of how to do it. So what we know from our slope-intercept form is that this is our y-intercept. It is -5. So here at -5 on the y-axis, this one's y, this one's x, I know that I have a point. The next thing I know is that I have a slope of -1/3. And again, I can put the negative on top, or I can put the negative on the bottom. It doesn't matter which I choose as long as I only choose one or the other. So let's, for the sake of doing something different, I'll use this one. It doesn't matter which one I use, right? As long as I know. So I'm going to go up 1 space, and then I'm going to go in the negative direction 1, 2, 3 spaces. And that, oops, I started from the wrong point. I went up 1 and then so I went up 1, and then I'm going in the negative direction 1, 2, 3 spaces. And then I can go ahead and just connect those 2 points. Only do better than me actually go through the point. What would have happened if I would have gone down 1 space and over 3? Well, I would have hit that point right about there, right? I'm still going to hit it. It's still going to happen the same way. It's just, it's going to hit on the other side going in the same direction, which is why you can do either one of those. There's a couple things to know in terms of slopes of lines. One is if I have 2 different lines, you can tell if lines are parallel or perpendicular by their slope. A parallel lines have the same slope. Does everyone know what a parallel line is? Parallel lines are any two lines that never intersect. They're always the same distance apart. They always travel together, but never ever get closer together. They never intersect. Forever and ever they won't intersect. And we know that because they have the same slope. What does that mean? It means if I have a line that's like y equals 3x plus 4, and I have a line that's y equals 3x minus 137, it doesn't matter because their slopes are both 3. Those lines will be parallel. They will never intersect. Doesn't matter what the equation is. If they have the same slope, they're never going to intersect. Perpendicular lines, on the other hand, have something that we call opposite reciprocal slopes. So parallel lines, right? Two lines that never intersect, right? That trying to do the symbol for parallel lines, but I'm having trouble writing on the tablet today. Parallel lines, two lines that never intersect. If you see two lines written like that as a symbol, it just means those lines are parallel. Perpendicular lines, on the other hand, are lines that intersect at a right angle. And you'll see a symbol that looks kind of like that. The reason we talk about them is because we're talking about slopes right now in general, right? And perpendicular lines, you can also tell by their slopes. They have what we call negative reciprocal slopes. So if I have y equals 3x plus 4, just like I did up above, the perpendicular line would have opposite. What I mean by opposite is opposite sign. If this one is positive, the opposite one would be negative. And what I mean by reciprocal is if I were to write 3 in a fractional form, it would be 3 over 1, right? The reciprocal of that flips the fraction, right? It would become 1 over 3. So it would be negative 1/3 x. And it could be plus or minus anything, right? So let's call it 2 or 200 or 2 million. It doesn't matter. What we know is as long as these slopes are opposite reciprocal, that those lines would be perpendicular. Does that make some sense? So if I have two lines, I'm trying to see what time this class lets out so that I don't keep you too late. If I have two lines, say 10x plus 5y equals 5, and negative x equals 2y plus 16. And I need to know, are these lines either parallel or perpendicular or neither? The first step would to be write them in slope-intercept form. Right? What does that mean? Have them set equal to y. We want y equals something. So we're just going to go ahead and move this 10x over. And I would have 5y equals minus 10x plus 5. And then we're still not in slope-intercept form because we have that 5 in front of the y. So we're going to divide it out. We've got to divide it by each piece. So we have y equals minus 2x plus 1. And so we're there, right? What is our slope? Our slope is negative 2. Here, I need to move my y to the other side. So I'm going to subtract 2y, which would give me minus 2y minus x equals 16. So we're going to get rid of that x now by adding it to the other side. And That is going to give me minus 2y equals x plus 16. And here we're going to divide each piece by negative 2. And I get y equals minus 1/2 x plus 16 divided by negative 2 is negative 8. So it wouldn't be plus, it would be minus. And now we're in slope-intercept form. Are these equations parallel, perpendicular, or neither? How do we tell? Let's look at the slopes. Here I have a minus 2. Here I have a minus 1/2. Everyone needs to answer in the chat box. Are they parallel, perpendicular, or neither? Parallel, equal slopes, right? Perpendicular, opposite reciprocal. Anything else would be neither. Parallel, perpendicular, or neither. If you don't answer in the chat box, then you aren't here. I'm going to mark you absent. So everybody put a choice in. You can do parallel, perpendicular, or neither.
So hopefully we're really close to finishing. Everything inventory.
1, 2, 3, 4.
If you're not, we only have a couple more minutes of class time left. You can get there through the district
1, 2,
website.
3, 4, 5, 6, 7, 8. There's 12 of you in here, 13 of you in here.
To make sure that I send them.
Michaela, do you have an answer? Giovanna, do you have an answer?
I will see you guys on Thursday. On Thursday, we're going to be looking at
Linda, do you have an answer?
Have a great day, guys.
There's actually only one right answer on the board, and that would go to Nathan. They are neither. Where is the confusion? I know exactly where it is. They are reciprocal slopes, right? They do flip over, but they both have negative signs, so they aren't opposite reciprocal slopes. So if I start with negative 2, I need to have positive 1/2 for it to be an opposite reciprocal slope. So keep that in mind. If your slope is negative, your perpendicular slope is going to be positive. If your slope is positive, your perpendicular slope is going to be negative. So I could see where everyone came up with perpendicular because it did flip, right? You did have that reciprocal, but you got to watch out for the signs because they will try and throw you off on that one in all of your assignments. The good news is for you is I did not get to the X and Y intercept part of this assignment, and we are running out of time, so we are not going to get to it. So I'm going to remove that one from, maybe I won't. Maybe I'll just post another video. Now I'll remove that from the Delta Math. I'll remove the X and Y intercept part of the problem, and we'll remove it from the worksheet too. I'll go in and change the instructions on the worksheet to not do the X and Y intercept portion. So you do have to do the parallel and perpendicular part, right? And you do have to do the graphing, the standard form and the slope intercept, but you don't have to do finding the X and Y intercepts right now. Okay, we will deal with that next week. So that is all I have for you today. Thank you for participating. Go away. Unless you have questions, and stick around. Bye, guys.